Hi everyone, welcome back to my channel again. Today we're going to be talking about generating test data. We've been talking about using Power Query and whatever. We need some test data. So this builds on the last couple of videos I've done of setting up an app service environment to host the CSV files, and also how to FTP, how to get data into that particular environment. So today we'll be generating some test data. Um, it's just rubbish, really, for me. I've just pulled it together just for the sake of the exercise. But generating test data is quite an important thing in a lot of in commercial um, places of work. When you're designing software, building software, it's very iterative these days, so it's quite useful to be able to have data to work on before the real database is there. So you can work with the database designers, the analysts, and whatever, find out what the structure is, be rebuilding the entity structure of the database, the fields, the columns, all the things we normally deal with, feeding back to developers or test data developers to actually work out and generate some data to go through the front end, or even to feed things like data warehouses. So understanding how your keys get distributed, what kind of keys you would use, how fast you can load them. So unless you do have some data, it's very, very difficult to do that. So when you do generate test data, it usually is nonsensical. But it is the fields, the actual field values, if you see what I'm saying, that you actually use. So for the sake of this example, I've just pulled together an application which just has an ID, which is a GUID. GUIDs are very popular as record IDs now. You find them all over Azure. You find them all over Dynamics as unique keys. So I've put one in. So it is generated. So they're all unique. I'll show you the code all to do this. This is usually the MAC address of the server that created it. So you could even change the uh, the addresses, because I've actually created the GUIDs as I've gone along dynamically, but you could create the left hand side, which is to do with timestamps and whatever, and the right hand side to do with the server. When you're loading things, for example with Dynamics 365, the customer engagement, as I said, that is the server, so you can actually see how you're inserting it and spread around servers, because you do get a variety, a number of web servers depending on how you set it up. Not to talk about here, but we might talk about it in the future. But there is an online document which explains all that, so you can. It's an interesting read if you're into Dynamics. So the rest of the file, we've just called it a day. I've given it the city where this particular shoe was sold, the shoe description itself, which I just took off Wikipedia. So I don't even know if half of these are shoes or not, but it doesn't matter for what we are doing, it's there. And then I've generated a dynamic price. So I've given it two extremes. The most cheap it can be and the most expensive it can be. So when you actually feed this into things like Power Query, you can find out who's prepared to pay the most for shoes. For example, do the people in Newcastle, will they pay more for a shoe? You can work that kind of thing out. It's all to do with insights and whatever not. So that's essentially the data. What I've done is I'll explain some quite complexity parts in this. When I've generated the data, I've just given it a week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Notice my spelling of Thursday. Cities. So we just select some cities. So these are just ones that come into my head. So Manchester, where I am, London, Birmingham, Leeds, Glasgow, York, Newcastle, Sunderland, Canterbury, Portsmouth, and Plymouth. If you're in the UK, you'll know these cities. If you're not in the UK, they're just cities. They're just cities. This is the file that I butchered from Wikipedia. So it is just names of shoes. I know Mary Jane's shoes. A lot of shoes actually the manufacturer. Just noticed that now, but again we're okay. So stiletto heels, steel toes for the working man. Down here, some odd Unicode characters in there. So we've got quite a few. There are 247. It'll be shoes. So that's quite a lot and do that. Now, when you use tools like PHP to generate the random numbers to go and get the data, tend to actually create quite a balanced uh, selection. Now, quite often when you're generating test data, you don't want to have that balance. You want to have particular spikes. Again, for when you're developing queries or seeing how indexes behave on certain values, you can do that. So what I've done is I've actually produced a little skewing formula. I use the terms skew and distribution interchangeably. How it all works is it's the same really. So when we generate the days, so we go off, so without any skewing, we go off and we choose one of seven. We'll get an equal percent. I think something 14% of your returns will be a Monday, 14% will be Tuesday, 40% will be Friday. But I want to just create some spikes around the Monday. So I've said I want to shift the distribution to be 25% of the transactions occurred on Mondays, 18% on Tuesday, and Friday at 20%. Now the rest will actually be for all the others. So that's what we're talking about: Wednesday, Thursday, Saturday, and Sunday. They will spread against the 30, 43, the 50 odd percent would divide across there, and that distribution will be exactly the same as we made no changes. The city skews is exactly the same. So you notice when we talk about cities, we have got 12 cities there. So the skews there said I want to see what happens in Manchester, London, Birmingham, and Sunderland. So there's a 5%, 10%, 4%, 28% skew. All the other cities, which I think comes around about 7%, will spread across there. So now looking at the code, it is fairly straightforward because there is no real logic in it other than the skewing logic. So we'll just walk through it. So because I'm dealing with dates, it's considered good practice to set your default time zones. Here we are, London. I'm in Manchester, but there isn't a Europe Manchester one, but we share a time with London, so we can use that. Now the scale up is interesting because when we looked at the table with the days in, because that is just days, you just get 7 in there. So when we do the skewing, when we work out the numbers, it could be that you need to insert zero point 0.5 of a block, 0.5 of an element to get the distribution, but you clearly can't do that. So if you had 0.5, you would have to multiply 10 to get 50. So that would be a good multiplier. So if you use a multiplier like 1,000, you'll probably get rid of most of the decimal places you'll ever see. By and large, the data you're using when you're generating test data won't be huge. If you're using things like postcodes or zip codes, it will be a large amount of numbers. So we probably couldn't use the technique here. But if we're just going to generate 2,000 or 3,000 elements, that's absolutely not a problem for any modern computer. So we can do that, and we can get that accuracy as well. So if we want 60%, we can have 60% rather than it maybe peaking out at 42 for whatever, or even worse, 75. You will get some accuracy, which is really good. Again, another hard-coded value here. This is how many you want to do. So I've said 1,000,000. You would normally put these things in a parameter file or take it from the command line when you run it, but because it's a demonstration, the code will eventually end up in a repo for you to download and have a look at. I like to have most things in one file so you can see it, because there's nothing worse than reading through a piece of code. You've been searching on Google for an hour, you find some code, and you think, yeah, this is how we do it. Then it turns out there's another library you need including, so you have to go and find that. So I try and include everything in there. You would normally have them in a library or a class, even how you want to do it. Delimiter, a comma. Very common to use a comma in what some people call a comma delimited file. Some people call it a character delimited file. Comma is quite good because that's the default in Excel. So when you're at the command prompt, the output file we create, which in our example will be ftp data.csv, if you just type that, if the association's set up, Excel will load the file. So you don't have to mess about with it when you're testing it. But when you're doing real data, you might want to use something like a tab there, because tabs are rarely in data from a commercial system. They might well be if you have some rubbish fields or binary fields in there. But comma delimited files do come with their penalties for being so easy to work with. But we'll just use a comma here, and that should work well, and it'll work well with Power Query, which also I think uses comma as its delimiter. Because I like to just show bits and pieces about what the likes of PHP can do. I've set some constants up here. This is how you do a constant in PHP, define. So I've said there's two ones here, include hyphens and no hyphens. They will be used when we generate the GUIDs. Some software likes to have the hyphen in there, some doesn't want the hyphen in there. So this is just how we can control that. Show progress at, so there's not a progress bar, but I am displaying every 100,000 records how far we're in a timestamp. If you're using a lot of rows, I mean, I'm doing 1 million, which is a lot, but it doesn't take a lot to generate. If you're generating 100 million, it might be quite nice to see how it's getting along. The last thing anybody wants is just need to start a program and it sits there and doesn't say anything for the next hour. Is it actually doing anything? You never know. So that's quite useful. And we might in the future show how we can do a progress bar again using the ANSI escape sequences that we did in an earlier video. So here's our data files. Here's our skews, which we're going to use. So we got which one we given first? The day skews. So we did those before, 25, 18, and 20, and the city skews as well. So we read those in. Here's our raw data file. So we have cities and days, which we looked at. So there's my cities, there's my days. They're just the values in there. And the shoes has no skew. It's just a file of shoes. And so we also just create a hard-coded output file. Sometimes with PHP or most languages, you can just display and pipe the output, but we're going to display some fields as we go through this. You don't want those ending up in your CSV file. So we're going to create the file ftp.csv. We're going to open the file as you would in C, for example. That's the name of our file, and we're going to open it for write. You could hard code the value in there, but again, if it's coming from a parameter file, it'd be easy to put it into a variable. We read in the file contents. So we have 3 arrays here. So we're just reading the JSON representation of the days, and we're converting them into an array, a PHP array. That value there, if that was false, that would create an object. So depending if you do PHP, if you're happy with doing arrays or doing objects, you can choose either way. In either way, our day file will end up in an array called days. It'll end up in one called cities and end up in one called shoes. So we then have to generate these skewing figures, as I've called them. So sometimes they're skewing, sometimes just say distribution. So it's a PHP function, and off we go. So we're passing in the days array. We'll create there. We're passing in the skews file. Now, just to save doing this work out here all the time, the function itself does the decode, does exactly the same piece of code there to remove it. And the scale of value that we're going to multiply everything by. And there's just a little message. So when the function runs, regenerate selection arrays, it will just say, I'm doing days, I'm doing cities, so you can see what's going on when the code's running. Then it'll help a function show the skews. So we'll pass in the raw data, we'll pass in the array we've created as skewed data. So that'll have 7 elements in that. For example, I think we set it 1,000. That will have 7,000 array values in it. Same for the cities. So we had 12 cities. We'll have 12,000 cities because it's skewed up. So what the show skews function does, it just displays what the distribution is. So it's just a debugging aid, a confidence aid that we're actually are generating that distribution correctly, and we'll see that when it runs. We create an array for our output, where we're going to use that twice because we're going to create a CSV file. The columns we have ID, day, city, shoe, and price. So we go back to our file. There's our ID, day, city, shoe, and price. When you put them in an array PHP, then we do an implode. There's the delimiter, the column, and we add a new line. You could just add these values up and say ID plus the delimiter plus the delimiter, day plus delimiter, city plus delimiter. But if you add items in there, you always have to make sure that you include the delimiter. It gets a bit messy. And when we actually generate the data, if we just keep on adding, we'll end up with a trailing comma. We have to do something about that. So if we use this implode, that works it all out for us. It's really quite good. So once we've written that line out, we need to actually generate the fake data. So you'll recall up here, we said we want to do 1 million. That's what I want to do. So here's our normal formatted for loop, which you'd see in many languages. So we'll start from 0 and we'll go up till it's less than or equal to 1 million. So there we go, we get that out. The unset clears out the output array because we're going to reuse that down the bottom. We're just going to keep on right inside array, so we don't want to get any funny data in there. We'll generate the GUID. So I'm going to use hyphens in this particular one. So I'll just pass in the hyphens constant. If we didn't want hyphens, just use this version instead. So use no hyphens. So in the actual output, you'll see we do have hyphens in there. It's just so we can read it a bit better when we use it. We then add that unique ID, that GUID, into the output array. We'll then need to generate a day. So this skewed days array is where we're going to get this data from. So when you reference arrays in PHP, it's with a square bracket. So we're going to get an element by number. So we will have created around about 70,000 days in there because we had to scale them up. We had that 1,000 scalability, so we have all those rows in there. So from that array, we just need to generate a random number because it's an array in PHP, starts at 0, and it'll just use the count of the number of elements. So that'd be, say, 70,000, and then we'll take 1 off, just because, for example, if there was 10, it would be 0 to 9 rather than 0 to 10. If you didn't do that, you would just get a few warnings saying an element doesn't exist, and the data would look silly as well, because it would probably just be blank. So that day, we add that into the output array as well. And we do exactly the same process for the skewed cities. So it's again, it's to count the cities. So we'll maybe have 100,000 cities, for example, in there. So that'd be from 0 to 99,999, whatever it is, -1. We'll add that city into the output. The shoes, we didn't mess about with the shoes. We just read it straight in. So again, 0 to the count -1 of the actual shoes you read in. We then want to generate a price. So I've just said generate a random number between 1,000 pennies and 2,500 pennies. We divide that by 2, we get an amount. So that'd be between £10 and £25 for a pair of shoes. We put that price into the array, so we now have a row. So we have that GUID, the day, the town, the type of shoe, and the price, town, city. We have that. So we then do this implode again. So using our delimiter, which is a comma in this case, and that array. So that creates the line with the commas in, and we add the end of line character, and we just write it out to the output file. Job done for that. We then go off and do our progress, and we said there we have this where we're going to show it every 100,000 rows as the input. It's probably quite efficient to do this because if we do 1,000,000 rows, we're going to make a million calls to the show progress function. So there is one line in there. It takes the modulus of the number of records we've done. And if it's 1,000, it'll actually output the row. So we can actually do that calculation here. And if it's 0, which is like I've done a round number of 1,000, 100,000, whatever, we can do the show progress. But again, when you see it run, it's fast enough to do this. Premature optimization's usually not the way to go when you're developing software. It's just optimize it if it does perform badly. So after we finish the loop, which is the curly brace there, so I've done that block of code. So we've written your million numbers out, and we just put commas in, make it look pretty. Records just to the output file, so we remember what it was. It was FTP data.csv. We write that out, and then close it, and that's the end of the program. So we do need these helper functions as we go down. So the first one, I've just done them in alphabetical order. How many needed? This is this thing where we're going to work out what 1% the value is. So from the 1% value, we have worked that out previously. So that this is the key part where we work out how many elements we need to represent 1% scaled up within the output array. Then we generate the GUID, and there's the thing with the hyphens. So if we pass in with hyphens, if that's true, so remember the values in those actual arrays in the constants were true and false, or whatever, true and false. Let's go back down again. There we go. So we're generating the bits of the GUID which we need to do only from the hex digits. We do that in 12 being the MAC address of the machine discussed earlier. So we're either going to format with a hyphen or we're not. So then we just string them together. So we just add up the parts we've done. That format costs the hyphen or space. We get the end bit, and then we return that GUID. So that's a fairly simple piece of code. It should return a perfectly valid GUID all of the time. So generating the arrays, which is the complex part, I've explained in the comments how that works. So we read the skewed file that's set up at the top. We rather than just doing all that in the main line of the code, because we're going to do more than once, we'll just do all of this in the file. So we're reading in the contents of the skew file into an array. Then we go and call the function which actually does that work. So we're passing in the base data. So for example, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We'll send in the force percents. So for the days, actually I think it's 3 for days. We did that on the skew for days. So that array will have 3 values in. So it knows how many to loop round to do that. And then we'll work out how many skewed. That's just, again, just for a bit of debug if you need to do that. I'm not actually going to display it. In fact, that's wrong, isn't it? I must have changed that. So I just need to change that to say C while I'm here, just in case we do that. We'll save that. There we go. So this is the function, generate skewed array. This is where we call it here. This is our core. This is where we actually do the hard work. You see, I've gone to town in the comments. The expanded array, that is what we're going to pass back. So that's going to become the array that we actually do use. So that's the one where rather than having 7 days in, it has 70,000 days in by the time we're finished. This is how we work out the remainders. So for example, when we've done city skews, in fact day skews is probably easier. So we're talking there 45, sorry, I should have done this, 45, 55, 63% of the total data will be skewed. So we just have to make sure that the remaining 70% doesn't get skewed. So we do that. So we work out 1%. So that's the count of the 7. That'll be 7 minus 100, which gives us that very small value. Here's our percentage required, remaining 100. So in the loop, as we go through those forces, so we go through 3 times here, and we'll work out how many we need, and then we'll remove that percentage to get down to that 45%, whatever it is we need to do at the end game. So this is where we work out how many we need. It works slightly differently how it scales, because basically because the scale ones do need to be scaled. The non-scalar ones don't need to be scaled, but do need to represent them. So if in the original array they were 10%, they still need to be 10% in the output array, or the shared 10%, if I'm saying that correctly. So if 60% of our output was skewed, that remaining 40% would need to be distributed over the 5 elements. So on the distribution when we actually use it is correct. So this is where we work that out. So we go around the 5. We see have we got it? We just work out here what we need to do. It's difficult to explain verbally, but if you read the code, you'll see what goes on. So for that 7 values, the base ones we had Monday to Saturday, if that key is in our needs array, that means that we have published it, we have calculated already. We'll work out the number needs as the value in needs, else it's not in there. So we have no skewing requirements, so that's our remaining elements. We do that. Then a little loop here, which goes around, and that's the one that actually starts putting the values into this expanded array, which is the one that gets passed back. That's probably the most complex piece of code in there. So this is our progress. So yeah, that's the modulus arithmetic I was talking about earlier on. So if we've actually come through here, so our progress at, and we think we said 10,000, 100,000, whatever. So when you modulus, how many have we done so far? With that, if it means 0, it means yeah, it's divided by that, so it's actually 0. So we're going to just display the date, time formatted, the current time, and then we'll just display that timestamp. We've done the number done out of the total number so far, and then we'll say how many we've got to go. So if you've got a million, that probably doesn't matter. If you've got 20 million, you can actually see it count down. It's nice for reusable code, really. So show the skews. This is just a bit of debugging. Just remember we did that show skews just after we displayed the values. Where are we? Just move slightly up. When we worked out, yeah, so the show skews just display that. So you might even comment that out. But it's useful just to get a little bit of confidence that your data has got that particular value in. So again, we just whip through 2 arrays, comparing them if they exist. we just either increment them. Your setup is 1 because that means it hasn't been found previously in the array, so it's a new value. We set it to 1. Then we just go through that table, we work out the proportion and display that. Little weird function, game for debugging, quite useful really. So you can put that after a line and it'll just say, well, I'm stopping the PHP, and off we go. You can just see what's displayed on the screen. So now, probably what you've all been waiting for is to actually run the code. So it's called dist3 PHP. I'll just try and make this font a little bit bigger. Where are we? Font all knowledge. We'll do that. There we are. It's a bit more there. So if we run this now, so remember we're doing 1,000,000 here, and we're done. I think you'll agree that was quite quick. So I've just dumped out the distribution that's in the showed skews. So in the original skewed file, we actually said that for Monday we wanted to have a distribution of 25%, and it's done that quite well. For Tuesday we wanted 80%, again it's done that quite well. And Friday 20%, again it's done that quite accurately as well. On the city skews for Manchester, I want 5%, it's just over 5%, so that's fine. London, where's our London gone? There we're at 10% exactly, which is the skew we wanted. Birmingham 4 just over, and Sunderland to 20%, exactly what we wanted. So if we'd have reduced that value from 1,000 down to maybe 100, we might not have gotten so much the accuracy, but at least given that number, we've got a really good accurate set of skews. So this is a little progress we've gone through. There's the first one. Yeah, just because you divide it by 0, you get that. So 1,000,000 to go at 11 minutes and 52 seconds past 11 minutes, that's 4. Then we just display the time. So it took us around about 5 seconds to generate 1,000,000 rows of data. So our FTP data file, just on 70 meg. Now I did write another piece of code as well, which is to show the file distribution. So it's all very well that we've seen that the arrays are distributed, but I've actually just coded this, so we just go through that and we find out, and it'll display the actual value. So the first time we'll go through, we'll take that out actually. It's because the first element, if you like, in the data will be the days, because the 0 element is the GUID. We don't want to mess with that. So we'll just do that. We'll save that back, and there's the hard-coded file. That's why we're hard-coded in there. We'll go back to here. So we do a PHP, it's got file distribution, and this actually takes a little bit longer than going through the actual file itself. So there's our 1,000,000 records. So this is for days, remember. So for Monday, and we said 25%. So when it's actually generated it's done 24.99, which is pretty close. Tuesday, 18.8, which is just over the 18% we said. And the Friday, 20%, just over that. So I've just displayed these down here just for reference to save looking at the code. So these are just a display of the actual JSON file. So there's a 20, 25, 18, and 20. If I go back to here, and we'll do the cities this time, which is the second element. So GUID day, then cities. We'll save that back. We'll come here and we'll just run the code again. There we are. So we've only got the skews for Manchester. We wanted 5%. So where's Manchester gone? There's Manchester, 5.01%, very close. London, where's our London? 9.97, it's very close to 10%. Birmingham, 4, exactly on 4. Sunderland, 28%. There we are, just that. So we've actually managed to generate the selection arrays for the values to a correct skew, and the code itself, we can see it's actually respected that. So we get a really good distribution from the rand function within PHP. So the actual output file is very representative of the skewing that we want internally. Of course, we don't have to do any skews. We just remove that out as we did the shoes. That's why we're not looking at shoes. But if you do need to do that, just to make it easier to you, the Power Query, that's absolutely fine. So the last thing we're going to do is we're just going to have a look at the open editors and the FTP client code. This is the client code that I wrote in one of the previous videos to actually upload files to the app service. So if you've seen that video, and I'll put links in the description, that's now the server that we need to go to. I think the last one we had was 71. This is the user, so this is the deployment user. That's I've already set up. I'm not going to go through this again. Again, I showed how to do that, and there's the password. So we just go through our PHP things, connect, log in, switch to passive, because we're behind a firewall, so we have to issue all the commands. We'll just display the directory. This is just exactly the same code. We go into the root, and where are we? That's our file FTP data that we want it to be on the remote server. This is the physical location where it is now on the machine I'm working on. I want it to be ASCII, so just message putting the file up, and we call the FTP put, so it'll actually do that transfer. So we just come down here now, and we'll just run this. So if I think it's in code, isn't it? It's not in this. It's in a different. There we are. So let's do PHP FTPS client. And this should be reasonably quick because we're actually running on Azure here. So if you recall, we did that. We showed the files that are in the folder first off. So there's that hosting start, which is what you get when you just display the website itself. And there's our FTP data file we've just put up. I've previously logged into the service, so there it is. So if we just switch to site, and then we switch to site, and switch to the best laid plans of mice and men. And there's our FTP data. There's our 69 mega files. So we're nearly at the end. And I thought what I'll do is, because the outcome of this whole exercise is to use the web control within the Power BI client. So what I'll do is, because we won't get a chance to do this, we'll just see what happens when we load in that file itself. So I've installed Power BI Desktop. It's free to download. So we'll say go and get the data from another source. This should give us a nice little menu. So we'll say we're going to bring in a text file. So we'll connect to a text file. So we just need to go to our Windows Drive. It's in this folder, and it's in test data, and there's our FTP data, comma separated file. We'll open that. Sometimes it takes a little bit of time in Power BI, but this is quite a powerful machine I'm working on. So there we are. You'll probably recognize that data. There are our GUIDs, our days, and whatever. So I'm quite happy that it's done that. We got a nice price. The type is Skew, the city was bought in, the date was bought on, and the GUID. So we'll just load that data. It'll give us a few messages. It should also tell us how much data we got. So there we are, 4250. Probably just have got all the data now. And it goes quiet. There we are. Got a million rows. Playing around, so it's actually loaded that data in now. So if we open this up, there we are. There's our files. Now, what I normally do is I like to do is a table. Come on. There's our table, and we want to display in there the city, the day. In fact, we'll display everything. We'll do that. There we go. So there's our pretty table. So there's the sorted nicely. Birmingham, done on Friday. I think if we scroll down, hopefully we'll get some days other than Friday. I was done in Birmingham. thinking there is a million in here, so it could, it could take us a while to find one. Or we could say city is all, day is. We'll do that and we'll just say, oh, we actually want to see the Monday ones. That's all we want to see. There we go. So there was some sold in Birmingham Monday. That's about the extent of my Power BI to do that. But that's the kind of thing we'll do. You have your visualizations as well. So up here we have a pie chart. Quickly generate that again. Million rows. Very quick. Why it does it in this particular order, I don't really know. But there's our towns down there. So this will be a reason. So we'll have like, where are we? 28.9% were from Sunderland, which is what we asked for on the skew, if you remember. And we asked for the Manchester one was 5%. So if you find Manchester, which is, I'm actually colourblind, so it can be a bit difficult sometimes. Is that Manchester? Yeah, 4.97%, which is near enough to 5. So we can see now that our scaling is actually applied to the data. So this is the kind of thing I was talking about at the beginning. You can actually move this through. We can play around with the data and get it to work nicely. So that's it. That's how we can generate some test data. Not limited to this. You can generate that test data as JSON files, or you could generate a relational model. We've just kind of generated a raw level data there. So we might even do some work in the future on that, how to play around with that. Yeah, it'd be good for developers to work with designers, so you can materialize a database long before you have any real data. You can load a data warehouse long before you have any data. See what the performance is. How many nodes would you need? How much parallel work would you need? You have a million, so you can actually load 10 streams of 100,000 if they're quite difficult things to load. So that would save you time. Cloud economics are odd, really, sometimes, because for a job that takes 100 hours, for example, using one machine usually takes about 1 hour for the same cost. So you have to be very understanding of your data, how you can shard it, partition it. There's all kinds of expressions for it these days. But it's well worth having a play around with, just doing that data. And you don't need to use my code, of course, but how you generate the data. You could be going to a database to get some values, longer values, postcodes. I mean, in the UK, there's getting on for maybe 1.75 million postcodes up to 2 million. Probably won't be long before there are 2 million postcodes. So you really wouldn't want to have that in a table. But again, you might. Depends what you do. 2 million postcodes at roughly 8 bytes each. Oh, it's not really a lot of data really. In languages like PHP, all modern languages, you can store enormous arrays. It's usually the time taken to read those rows, load them when there are other techniques to do that. And again, we might look at that in the future. It depends how we feel really to do that, or if people request it to find different ways. Yeah, so that's it, guys. Thanks for watching again. If you could do the subscribe, the likes, it all helps the engagement model. And next time we'll hopefully do some work actually on the Power Query, talking to a web-based backend. So until then, everybody keep safe, and I'll speak to you soon. Cheers.